Okay, thank you. All right, so let us share the slide. Okay, just to check. Going to open a poll as usual. So, all right, just to check whether you are able to see my screen. All right, I think you can able to see my screen, right? Okay, just let me see the poll result. Yes, most of the time you are able to see, so therefore, okay, fine. Let us move forward. Any doubt in previous class? Relationship between k and alpha beta I'm going to discuss again, so therefore don't worry about that. Previous thing, is it clear? Okay, all right. If you have anything to share, you can always raise your hand and you can put it in the chat box also. Okay. All right. Let me go to full screen mode. All right. So now we are going to see the relationship between k, alpha, beta. Okay. So already we have seen relationship between Young's modulus, rigidity modulus, and Poisson's ratio. That is capital Y, eta, and sigma. That is what exactly we have seen yesterday. Okay. So now we are going to see relationship between k, alpha, and beta. My voice is clear, right? Just put it in the chat box. You can hear me, right? Okay, okay, thank you, thank you. All right, all right. Next, so let us consider a unit cube. Okay, let's consider unit cube having unit length. Okay, so you can see that there is a unit cube, unit length. Okay, now what you have to do is consider this cube, consider this unit cube, and one of the vertices, one of the corner of the cube lies at the coordinate. So let us consider, actually what we are considering the xy coordinate, xy z coordinates for the cube. Okay, its origin, let us say O is the origin, O is the origin. Now let us assume a tensile force is acting on this cube. How exactly it is acting? Tensile force means two opposite forces are acting. Two opposite forces are acting. Okay, all right. So what are the two opposite phases? So let us consider pair of phases. So x direction phase pair, let us say tx tx. So they are the opposite forces. You can see here they are opposite in nature. Similarly ty ty, that is front and back face, force acting on front and back face of the cube. Okay, that is Ty, Ty. Similarly, Tz, that is the bottom and top face of the cube, a force acting on the bottom and top face of the cube, that's known as Tz. Okay, now let us assume alpha is the extension per unit tension along direction of the force. Okay, so alpha, let us say extension per unit tension is related to stress. Okay, it's related to stress. Okay, let us say a fixed, let us say, take it as unity, unit tension is acting on the face, then extension, the amount of extension, let us say alpha, that is for unit tension along direction of the force. That may be x direction, y direction, z direction. Whatever extension we obtain because of the force in that particular direction, we call it as alpha. Okay. Similarly, beta is a contraction per unit tension again. Beta is a contraction per unit tension in the direction perpendicular to the force. What exactly that? Let us try to understand. Suppose let us consider the tensile force Tx acting along the x direction. Two opposite force which is acting along x direction. So left and right face of the cube, you can see the arrow mark. Tx is acting in the x direction. Then there is an extension along Ox. Along Ox, along coordinate Ox, there is a extension, increase in the length. Increase in the length. That amount, let us say, alpha is the extension. At the same time, there is a contraction. So now just we are assuming only force is acting in the x direction. Okay. So because of the force acting on the x direction, there will be a contraction on OY and OZ direction. Correct? Now we have understood that there is a longitudinal strain and lateral strain. Whenever there is a longitudinal strain, there is a lateral strain also, that we have understood. Same thing here, a lateral strain, because of the lateral strain, there will be a contraction. There will be a contraction along OY, OY and OZ. Okay? Alright. So, then what will be the length of this side? OX. What will be the length? Because of this resultant length. That is OX is equal to 1. 1 because we have considered cube of unit length. So therefore 1 is the initial length. Initial length. The extra length, what is the extension occur? That is because of Tx, alpha is the extension. So therefore component is alpha into Tx. Alpha into Tx. Alpha is for unit tension. Please understand that why it is alpha into Tx. Alpha is for per unit tension. Now tension is Tx. So therefore alpha into Tx minus because these are the contractions. These are the contraction. That component lead to on OX direction, that can be minus beta y Ty minus beta z, I mean beta Tz. Beta Tz. Okay. Similarly, the same argument, what we have put forward for x direction, the same argument you can put it for y direction also. Y direction also. The force is acting along, that is tensile force acting along the y direction, that is x direction, y direction, that is Ty. Okay. Then there will be extension along OY, contraction along OX and OZ. The same way you can talk in terms of Z direction, that is Tz is acting. Okay. So then there is a extension along OZ direction, contraction along OX and OY direction. So therefore, so length in the other two sides you can write it as the same manner. OY is equal to 1 plus 1 is unity plus alpha into Ty. Extension is always alpha. In which direction? Ty is a tension, so therefore alpha Ty minus contraction beta Tx minus beta Tz. Beta Tx minus beta Tz. Okay. In the same way, you can go for OZ direction 1 plus alpha Tz minus beta Tx minus beta Ty. Is it clear so far? Any clarification is required? If it is required, either raise your hand or put it in the chat. Okay, it's clear? If it is clear, put it in the chat. Okay. Okay. It's clear. Fine. 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 All right. Uh, let's go to next slide. So, all right. Sorry. All right. So, three sides length we have found out. So then, what will be the volume of this cube? That because of after applying tensile force, that will be uh, volume of the cube will be OX into OY into OZ. Three side length. If you multiply, you will get volume of the cube. Okay. So substitute the value of OX, OY and OZ. Just you have to substitute the value of OX, OY, OZ. Alright. So let us substitute that. OX is nothing but V is equal to 1 plus alpha Tx minus beta Ty minus beta Tz into OY 1 plus alpha Ty minus beta Tx minus beta Tz into OZ is 1 plus alpha Tz plus beta Tx minus beta Ty. On multiplication, and simplification, what exactly we do is if you multiply 1 into 1, so again 1, so 1 will be remaining, then second term you take multiply alpha into tx, okay, then alpha square ty tx ty, okay, like that you will get alpha beta, so you will get the different terms, but we are going to consider only first power of alpha and beta. Higher power of alpha beta is neglected because already alpha beta itself is a small quantity. Extension or contraction is a small quantity. So then there is no point in highest terms will be a smaller quantity, still smaller quantity, that will be negligible compared to 1. So therefore we are going to consider only this term alpha minus 2 beta into tx plus ty plus tz. Okay, higher terms are neglected. Suppose if you consider the tensile force which is acting, Tx, Ty, Tz, they are equal if they are all three direction. If they are equal, let us call it as T. Then your expression reduces to volume of the expression cube is equal to 1 plus alpha minus 2 beta into 3t, because it is t plus t plus t. So it becomes 3t. Okay, 1 plus alpha minus 2 beta into 3t. Fine. Is it okay? All right. Next, What was the original volume of the cube before applying the tensile force? All three sides are unity, so therefore 1 into 1 into 1, so therefore it is 1 meter cube. Okay? Okay? Alright? So volume of the cube you have after applying the force, original volume you have. If you want to find out change in volume, what do you have to do? Original volume, so change in that is final volume minus original volume. Now current volume of the cube, that is 1 plus alpha minus 2 beta into 3t minus original volume of the cube, that is 1 beta cube. So therefore subtract that. So you are left with 3t into alpha minus 2 beta. So 3t into alpha minus 2 beta is a change in volume of the cube. So now you have the original volume of the cube, change in volume of the cube. So therefore you can find out volume strain. You can find out volume strain. What is volume strain? Volume strain is nothing but, okay, 1 second. Okay, volume strain is nothing but change in volume divided by original volume. Change in dimension to the original dimension. Here it is volume. So therefore, change in volume to original volume ratio. So that is, you have the value, change in volume is 3t alpha minus 2 beta, correct? So change in volume is k 3t into alpha minus 2 beta, original volume is 1. So therefore 3t into alpha minus 2 beta divided by 1. So you are left with 3t into alpha minus 2 beta. So you got volume strain. So now you can find out what is bulk modulus now. So because you have the strain, bulk modulus is given by a stress by volume strain. Stress by strain is a general formula. So here, depending on what type of stress and strain, you will get a different modulus. So bulk modulus means stress by volume strain. So what is stress? Stress, as just now you have concluded, that is all three direction it is acting same stress, experiencing same stress. So therefore T is the stress, okay, divided by volume strain. Just now you have found out that is 3t into alpha minus 2 beta. Okay, you got the relationship now. What is the relationship? You are trying to find out relationship between bulk modulus, alpha and beta, longitudinal strain and lateral strain. Okay. So you got the relation. So that is K is equal to 1 by 3 into alpha minus 2 beta, because Tt will get cancelled. Correct na? Here T and T will get cancel. So therefore you will get 1 by 3 into alpha minus 2 beta. Okay. Is it clear? If it is clear, let us go to find out the next expression. Okay. All right. So let me go to next one. So next, let us find out another set of relationship between elastic constants. What is that? That is between Young's modulus and bulk modulus and Poisson's ratio. Okay, Young's modulus Y, bulk modulus K, and Poisson's ratio. What was initially we found out? Young's modulus, rigidity modulus, Poisson's ratio. So now instead of rigidity modulus, you are going to find out bulk modulus. Okay. What is a Young's modulus? Young's modulus is given by stress by longitudinal strain. So what we will do is, let us consider stress as a unit. Okay, for a unit stress, for simplification, for a unit stress, then longitudinal strain is alpha. Okay, so therefore Young's modulus is given by 1 by alpha. Here there is a small mistake, correct it. This should be, there is no, this one not 1 by alpha. Okay, I made a typo error there. Okay, so stress is unit stress, then longitudinal stress strain is given by alpha. Okay, alpha. So therefore Young's modulus is given by 1 by alpha, stress by strain. Okay, so make that correction while noting down. Okay, this part is not there, so I removed. Okay, all right. So that Young's modulus, let us call it as equation 2. Equation 1, you can recall, that is a previous expression, relationship between k, alpha and beta. I have called it as equation 1. All these are subheading. Okay, all this relationship between y, k and sigma. So main heading is relationship between elastic constants. Okay, all these are subheading relationship. Don't think that separate topic. So we have started uh, last class. Last class we have started with relationship between elastic constants. Okay, even in the exam also they will ask this question, they will split. Okay, uh, so you have to read the question carefully and answer. Okay, Poisson's ratio is defined as sigma is equal to beta by alpha, that is by definition. Okay, so equation 1, what it says, bulk modulus is equal to k is equal to, so already you have seen that. So this is equation 1. Okay, k is equal to 1 by 3 into alpha minus 2 beta. Now it is simple, just rewriting mathematical. Okay, so let us rewrite that expression of k. What we will do is, let us take alpha as a common term, whatever we did in the this one also. What is that? Relationship between Young's modulus, rigidity modulus and sigma, we did the same thing. There also we took alpha as common outside. Okay, in the rigidity modulus expression, same thing we are going to do here also. Take alpha as common factor. So then rewrite that alpha, you take it to numerator, so therefore the term becomes 1 by alpha, okay, divided by 3 into 1 minus 2 beta by alpha. So now it is simple. What is 1 by alpha? 1 by alpha is nothing but y, Young's modulus. Okay, what is beta by alpha? Beta by alpha is sigma, correct? Beta by alpha is sigma. So therefore you will get k is equal to y divided by 3 into 1 minus 2 sigma. So this is a relationship between Young's modulus, bulk modulus and Poisson's ratio. Is it okay? Is it clear? Any doubt? If it is there, you can raise your hand, or you can unmute yourself, because I have kept unmuting option open, or you can raise your hand. I will unmute you. Yes, it's clear, right? Okay. My screen is visible? Okay, okay. Because suddenly WebEx told it's not visible to participants. So that's why I asked. Okay. All right. All right. All right. All right. So then let me move forward. Next, let us find out relationship between Young's modulus, bulk modulus, and rigidity modulus. Okay. Relationship between Young's modulus, bulk modulus, rigidity modulus. So Y is for Young's modulus, K is for bulk modulus, eta is for rigidity modulus. Okay. All right. So just now we have seen the expression for bulk modulus. It is that K is equal to relationship with bulk modulus and sigma, that is sigma. We got expression, that is K is equal to Y by 3 into 1 minus 2 sigma. That can be rewritten in terms of expression for Young's modulus, that is take the denominator term to the other left hand side. Okay, so therefore you will get Y is equal to 3K into 1 minus 2 sigma. Call that as expression A. So another expression you have Young's modulus. This is in terms of rigidity modulus at first relationship we have seen. Okay. So that says Y is equal to 2 eta into 1 plus sigma, where eta is a rigidity modulus, sigma is a Poisson's ratio. Of course, K is a bulk modulus. Okay. So what we will do is we will rewrite that equation A and B. Both equation. Let us rewrite. How we are going to rewrite? 1 second, students. I am getting an important call. I'll Sorry for the inconvenience. I'm back. All right. So let us rewrite that equations. Okay. So first equation, that is A, we will rewrite it as let us take this 3K to the left hand side. So therefore you can write it as Y by 3K is equal to 1 minus 2 sigma. Okay. The same manner, equation B, what we do is the eta we'll take it to left hand side. Okay. So therefore you will get Y by eta is equal to 2 into 1 plus sigma. Okay. So therefore that is you can write it as 2, take it inside, 2 you can take it inside, so therefore you can write it as Y by eta is equal to 2 plus 2 sigma. 2 plus 2 sigma. Okay. So now what you do is let us add equation C and D. Adding equation C and D. Okay. Add the equation C and D. What happens when you add C equation C and D? What you can see is left hand side, that is y by 3k. Y by 3k. This you are going to add. Okay. So this you are going to add y by 3k plus y by eta. Okay. That's equal to, when you add, what happens? This is 1 minus 2 sigma. This is 2 plus 2 sigma. So 1 plus 2, okay, that is 3, minus 2 sigma. This is minus, this is plus. So therefore you will get 3. So this will get cancelled. Correct? That will get cancelled. Right? So therefore you are left with 1 by, so what we are going to do, this Young's modulus, which is a common term on left hand side, you divide with y. Okay, I'll do that. So Vinyashri is asking for repeat. Okay, no problem. So you got the relationship between two relations C and D. So to get your task, what is that? Our aim is to find out relationship between eta k, sorry, y, k and eta. Correct? So other term is not required. So now two independent term you have. You can see two expression. The two expression here, y is there, k is there, sigma is there, which is not required. Y is there, eta is there, sigma is there, sigma, which is not required. We want relationship with a expression with term involved y, k, eta. Now with the two different term it is there, two different expression, three terms are there. So what we do, we add this. Okay, C and D we are going to add C and D. So how exactly you do that? So adding, what happens? Left hand side you see eta y by 3k. Okay, y by 3k plus y by eta. Okay, added. So therefore you got y by 3k plus y by eta. That's equal to adding right hand side. So 1 plus 2. Okay, 1 plus 2, 3. When you add the second term of right hand side, and that is expression C, and second term of expression D, that is minus 2 sigma plus 2 sigma, that cancel each other. Correct? That cancels. So therefore you are left with 3. So now what you see is y is common in the numerator on left hand side. So therefore just divide with y. So you will get 1 by 3k plus 1 by eta is equal to 3 by y. Is it okay? Okay, fine. So now just make the expression simple. What do you do? So 1 3 is there. So therefore multiply by 3. So then that becomes 3 into 3, that is 9. 9 by y is equal to 3 get cancelled. So therefore 1 by k plus 3 by eta. So this is what exactly the final expression. Okay, fine. This is a final relationship between y, k and eta. So this expression. Fine. All right. It's time. Okay. Slightly we are moving forward. Okay, slightly moving forward. What we are going to do is we take the previous expression a and b, a and b. We try to get one relationship as we have done. What is that? We have done relationship between uh, y. Just now we have seen relationship between Young's modulus, bulk modulus and eta. Correct? Y, k and eta. Now we are going to little further. So we are try to relate all four. So far you have seen individual expression. What is that? If any three relationship between any three, either y, eta, sigma. You have seen y, k, sigma. Now you have seen y, eta, y, k, sigma you have seen. So now just let us see all four. Can we get a relation between all four? Yes, k alpha beta, that's also there. Okay, k alpha beta. So, all right. So, just let me take that expression once again. Y is equal to 3k into 1 minus 2 sigma, y is equal to eta 1 plus 2 sigma, whatever we have seen in the previous slide. Okay. So, from equation A and B, what do you have? So, left hand side of the equation, that is common, correct? So this is Young's modulus. So therefore equate that on equating 2 eta 1 plus sigma is equal to 3k 1 minus 2 sigma. Okay. All right. So now let us take that okay, before that let me take 2 eta inside, 2 eta inside. One second, I'm getting a call again, sorry. Hello, sorry for the disturbance. Yeah, screen you can, it's visible, right? My screen is visible. You can see the equations are coming. Okay, okay, okay. All right, fine. Thank you. Okay. So now, what we will do is we take that 2 eta, 2 eta inside the bracket. So therefore, it becomes 2 eta plus 2 eta plus 2 eta sigma. In the same way, let us take 3k inside the bracket. Let us expand. So 3k minus 6k sigma. Okay. All right. So now, Let us move further. So let us rewrite the expression. What we are going to do is, you can see here, sigma is common. Sigma is common. Here sigma term is there. Here sigma term is there. So let us write sigma term together. Let us write sigma term together. So that means you take this term to left hand side. So therefore what happens, and take sigma outside. So sigma into 2 eta, sigma into 2 eta plus 6k, 6k, okay, that is equal to 3k, that is as such, minus 2 eta. Is it okay? All right. So now rewriting, because we have to get the relationship. So now take that term, which is at 2 eta 6k to the right hand side. So therefore it becomes sigma is equal to 3k minus 2 eta divided by 2 eta plus 6k. Okay. So therefore you got an expression relating all four terms, which is at Poisson's ratio, bulk modulus, rigidity modulus. Okay. But of course here Young's modulus is eliminated, and you get okay. All right, so we got different relationships. So now what are that? One is different elastic constant. First one we have seen, that is y eta sigma. Then we have seen k alpha beta. Then y k sigma. Then you have seen relationship between y k eta. Now you have seen sigma k eta. Okay. So okay, I am not going further because next topic is limiting value of Poisson's ratio. Before going to that, any doubt, any clarification is required? Okay, this is a big question. So generally what they will do is, they may say, no, what they will do is, they will ask, obtain relation between Poisson's ratio, bulk modulus and rigidity modulus. If it is asked, you cannot start from here. Y is equal to 3k is 1 minus 2 sigma directly. No. There you cannot start. So that means you have to start somewhere. Where is that? Yes. From here you have to start. Okay. So here you have to start. So from here if you start, then one by one you have to develop. So that is what exactly you have to do. So if it is asked for this relationship, sigma is equal to 3k minus 2 eta divided by 2 eta plus 6k, so it will be something like 8 marks or 10 marks. If it is asked for relationship between what is that, Young's modulus, bulk modulus and rigidity modulus, that may be for 6 mark. So relationship may be asked between k, y and sigma. This may be 4 marks or 5 marks. Like that, marks also will vary. Okay. Marks also will vary depending on what exactly asked. Okay. So this is one set. So this is a one position where you can stop something like that. They will, depending on the mark, you have to write. Okay. All right. So let me take attendance poll. I'll give 1 minute time to answer the attendance. Okay, open the poll. Yes, starts. Attendance poll started. Give your attendance. All right. So, anything else you want a clarification? Actually, very important topic we are discussing. Not from the point of view examination and other thing. So this is actually from the point of view of okay, if attendance is taken means people can exit. Okay, good. So people are leaving the meeting, I can see before I am leaving. So what I will do is I'll take one more attendance. Okay, I'll take one more attendance now. Because before I stop the class, if it is leaving means okay, give the attendance now. That's too much. Okay. All right. So this is an important point, topic from the engineering point of view. So therefore, it's not just a point of view of the what is that? Just for the purpose of physics. No, it is very important point. So this maybe people may be thinking, I'm computer science. Why I have to worry? Why I'm electronic and communication? Why I have to worry? I am from AML. Why I have to worry? The same way people may be from ISC may be thinking, mine is computer science, why I have to worry? Only people from mechanical engineering and civil engineering has to worry about elasticity. No, no. This is a very significant topic. So in computer science, processes, fabrication of processors, the modulus plays a very important role. Young's modulus plays a very important role in the case of computer processor. Okay, that is what is it? Bulk modulus. To make that processor, bulk modulus of the processor is very important. In which direction you are cutting the ICs, chips, I mean silicon chip is very important. When it comes to electronics and communication, there is a mechanism, that is cantilever mechanism. Of course, next I am going to discuss after this topic cantilever. There I am going to discuss uh, what exactly significance of cantilever and other thing. So cantilever is a very important thing in the case of electronics and communication. How exactly it is important and other thing I will discuss in next class. Okay. Of course, for civil and mechanical engineering, no need to explain. People will understand that. What is the significance of elasticity? Okay. Anyway, let us wind it let us call the day. So thank you for joining. Let us meet tomorrow. Thank you.